Okay, stream started. All right, I have to start entertaining the viewers. Look at this trampoline. Oh, it's so bad. Oh, I gotta love physics. Okay. All right, we got 2 viewers so far. Just give it a little bit of time. Should be racking in the viewers. Real BrawlDev. Let's go. Leahy's in here. So guys, in today's live stream, we're going to be learning about physics. Just watch me make this really scuffed trampoline. Oh, but look at it. Look at it, though. It didn't even take me that much time to make this. You can find so many ways to break this. Alright, but I'm just going to be waiting in on a few more people. We got about 3 viewers. I'm just waiting for the live ping notification in my server. Okay, it already happened. Even the trampoline on the crossroads is better? No way, bro. No way. Okay, alright. My notification went live, so I think I'm just gonna go ahead and start. How's your guys' Wednesday? How's everyone doing? I know it's been quite a bit of time since I've went online, whether that's on YouTube or on Twitch, because I've kind of been busy doing stuff. But my summer break has now started, and I'll be updating you guys on what's been going on for like the past few months. So for you guys who are watching the stream right now, you guys are gonna be the first people to hear the origin of the story, I guess if you want to call it. But then sometime next week, when I finish recording my next video that's gonna go up on the channel, I'm gonna do a stream on YouTube, kind of like explaining what's been going on with me, where have I been. I've kind of like disappeared from the platform for quite a bit. I think it's been like 2 months or so since I last uploaded. So yeah, I will let you guys in on some stuff that's been going on and some things to expect for the future. Dako175, how's it going? It's Phobos, how's it going? Shadowceptions? Real BrawlDev. If you see this jump twice, I am seeing it. I mean, I don't need to jump twice to see it. I'm saying it on stream right now, so. But yeah, guys. Alright, so here's what I want to start with saying. I'm sorry. I've kind of disappeared for the past like 2 months. This is one of my longest breaks that I've taken on YouTube, and I didn't even talk about me going on break, because before when I went on a break, I did talk about how I was going to step down from the channel a little bit, from uploading 1 video a week to like 1 video every month or so. That was a big change that I made to my channel, where because of college, I wasn't able to do BrawlDev as much as I wanted to, so I had to step down and still make videos on the platform, but not do it at a very consistent rate, because I still wanted to make really good quality content on YouTube, and I didn't want my time constraint to affect that. And I did make a stream talking about that, but this time I disappeared for 2 months without even saying anything. That's because I was locked in during my final semester of college, which, if you're wondering about that, I have graduated from college. So now I'm done with my studies. It's actually really insane how I started BrawlDev while I was in college, because I know a lot of people would not be able to do that, considering how stressful it can be. But now that that's over, it is currently May 21, 2025, and I now have these next couple months to fully lock in on BrawlDev. There's a lot of content that I have just stored in my document that's full of all these video ideas and all these series ideas that I wanted to start a long time ago, but I wasn't able to do it because I didn't have the time to do it. And that is something that I'm very much looking forward to. I'm going to be starting a bunch of series. I'm going to be starting some one-off entertainment content, one-off educational content. I'm gonna try scaling my team as well, because I want to do BrawlDev full time and I want to take this seriously for the next couple months. I'm probably gonna be hiring some video editors, probably gonna be hiring some thumbnail designers. I might put out like an application of some sort just to see who would be willing to fully lock in and commit to this channel just as much as me. At least I'm hoping I can find some people in this community who are able to provide the same value as me. But yeah, let's go Unk status. That's right, I'm now an Unk. 50 videos a month is a little crazy. I don't know if I'd be able to do that. Okay, I still want to keep the same level of quality and consistency in my videos, so I don't want to sacrifice that by producing as many videos as possible. 2 videos a day, heck nah. You're a fossil now, BrawlDev. I know. It is quite unfortunate. Become lanky blocks, dude. If I had to resort to 2 videos a day of the most brain-rotty content imaginable that appeals to 5-year-olds, I would not be happy about that. I really like the channel that I've built. I would not want to, even if I was offered to take over Lanky Blocks' channel, I would not want to do that. Just because I wouldn't be happy making those videos. But yeah. Yad say, hello, how's it going? I love brain rot, don't deny it. Hey, salad bowls. Who let you inside this stream? What you doing? I'm gonna be getting to that. We're gonna be learning about physics inside of Roblox Studio. But before we get into that, I did want to just give you guys some updates, which I already have. But there's also another thing I want to update you guys on, and that is the advanced scripting tutorial guide. So I know over the past couple months, or actually no, honestly, ever since the creation of this channel, you guys have been curious about when is the advanced scripting tutorial guide going to be over? When is it going to finish? Is it already finished? Like those types of questions have been lingering around on my channel for the longest time, and you guys are going to be the first to hear how many episodes there are left on this channel, or not on this channel, on the advanced scripting tutorial guide. So let me just pull up my channel. While I do that, check out this trampoline that I created. It's very scuffed. It's really funny. It's really unstable. I feel like you can easily break stuff if this was inside of any one of my games. Okay, anyways, I'm gonna jump down. Okay. So, I think you guys can see this. Let me just move this. Oh. I don't want to have technical problems this early. It is not going to happen. Okay, I'm getting a feel for coming back to streaming because it's been a long time. So, anyways, here we go. Advanced Scripting Tutorial Guide. So, the first episode was released in October of 2023, around the start of this channel. Then, for the next year and a half, I think it's coming closer to 2 years now since I started this Advanced Scripting Tutorial Guide. It's actually really insane how long this journey's been. But anyways, the most recent video came out a little over 2 months ago, which is pathfinding, and it did really well views-wise, because pathfinding is a really popular concept. Okay, does anyone have guesses how many episodes are left in the Advanced Scripting Tutorial Guide? I'm about to tell you guys the exact number of episodes that there are left, and for you guys that are watching the stream right now, I'm gonna give you an exact number. So I want some guesses in the chat. Anyways, what have you guys been saying before? So live tutorial, make Brawl Egg when? Do you have anything about AI on your channel? I do, it's the most recent episode, which is pathfinding. BrawlDev figures when? Oh, dude, like, yeah, BrawlDev plushies. You know, like, I actually did look into creating BrawlDev plushies because I really want to make a BrawlDev plushie, and I want to be able to sell to you guys. So I did a little bit of research, and the average price for a plushie to be manufactured and sold. Or actually, like, usually people sell them for about $25 to $30. So I'll ask you guys later in the stream if that's something you guys would actually want. But first, let me answer the question of how many episodes there are in the advanced scripting tutorial guide. So some of you have been saying 3, 5, 1, 4, 55 is insane. 20, 8, 7, 89, that's a little much. 100, 999. Oh heck no, bro. I'd be retired before I finish the advanced scripting tutorial guide. It's 5 since you said there will be 40. I don't know when I said there was going to be 40. I did remember saying that there was going to be either 40 or less than 40. But these are pretty good guesses. Anyways, okay. The number of episodes left on the advanced scripting tutorial guide. That was a bad attempt to drum roll. But anyways, it's this. You see that? You see that right there? Easy. Oh my god. Look at it. Look at it. But by the way, if you're asking, yes, I had this ready for no reason. But yeah, 3. There's 3 advanced scripting episodes left on this tutorial guide. And I wanted to finish this a long time ago, but again, things with college kind of just ruined everything. So for these next few months, I will definitely be able to get these next 3 episodes out on the advanced scripting tutorial guide, and then I'll be done. Now, the thing is, Roblox is going to push out a new update that's going to be about the new studio generation UI or whatever. So basically, all of these episodes are going to become obsolete because they don't follow the new studio UI. Like, I think you guys know what I'm talking about. So it's like Roblox new studio UI. It's just completely different from the one that's before. It's like more customizable, stuff like that. Wait, I'm trying to find it. Yeah, here we go. The new UI. So Roblox said that they're going to push this out to all developers, and it's going to go out of beta at like the end of June. And what that means is all of my tutorials are going to become obsolete because it's not going to follow the exact same style. Or it's not going to follow the exact same UI layout. So it's going to be harder for new developers to follow along with everything. So if that happens, I will be able to recreate the beginner scripting tutorial guide easily. But the advanced scripting tutorial guide, I did say at the start of this channel that I was not ever going to remake the advanced scripting tutorial guide on YouTube. And I still think that kind of holds true. If it took me 2 years, almost 2 years to make the entire advanced scripting tutorial guide, I just don't think it's worth recreating it. I'm just going to let the advanced scripting tutorial guide be what it is. And just keep it on the platform for anyone to watch, no matter how obsolete the advanced scripting tutorial guide becomes. And there already are some episodes that are obsolete now. Like I think, yeah, one of you guys mentioned it. It was, yeah, the haptic service tutorial is outdated. It is. It's so unfortunate. I made it 3 months ago, and now Roblox released. Oh, I did not mean to click that. Roblox released. It was like haptic objects or something. I forgot. Oh no, it was like, what was it called? They released a new update. It was like haptic effects. That's what it's called. Yeah, haptic effects. Haptic effects. Yeah, that's what it was. So they released haptic effects, which immediately made this episode obsolete, which is unfortunate, but it's whatever. Like the cycle is just going to repeat. I'm gonna become Dev King, where there's going to be developers in the future who are going to be looking for tutorial guides. They look at my tutorial guides. Some of the things that are talked about here are obsolete. And then there's going to be someone else who supersedes me in creating Roblox scripting tutorials. And then the fans of those developers or of those YouTubers who succeed me are going to be like, oh yeah, BrawlDev is outdated. You should not watch him. It's the same thing with the Dev King. It's just a cycle that's going to keep happening. That is crazy to think about that. I am pretty much the superseded version of the Dev King. I actually used to watch the Dev King. Um, he was one of my inspirations to do what I do because I really liked his tutorial guides back during COVID times. Yeah, it's like around there. Semi-32, how's it going? Bush, how's it going, Bush? Glad you could tune into the stream. Bro hasn't streamed in ages. Yeah, that's right. Like I did address in the beginning of the stream that I was kind of busy with college, but now college is over, so I have all the time to focus on BrawlDev now. So do we get Roblox expert scripting next? And then after that, Roblox aficionado scripting. I don't even know what that means, but expert scripting. My plan was I'm not going to make it on YouTube, but if I were to ever do that, it would be on a course. And the thing about the course is I'm actually not sure if that's something I'm still going to do either. It really depends how easily and how efficiently I'm going to be able to make all of the episodes in the expert scripting tutorial guide. Because if the advanced scripting tutorial guide took me 2 years to make, who knows how long the expert scripting tutorial guide is. Like, I do have a roadmap and a plan of all the episodes that are going to be in the expert scripting tutorial guide, but the time that it'll take to make all of them will probably be a while. Oh, my trampoline just broke. That's great. To be fair, you should rename advanced to intermediate and call expert advanced. I guess, like, advanced is very subjective when it comes to what you define as advanced or intermediate. But I think from a YouTube standpoint, I think advanced just sounds cooler than intermediate and then advanced. Although it might have made things more organized if I did call it beginners, then intermediate, then advanced. Or if I took some elements from advanced and just made that into intermediate, then intermediate would be shorter, or then advanced would be shorter because some of those episodes would be in intermediate. And I feel like that would be easier to follow along. I still regret like the beginning of the advanced scripting tutorial guide where like I don't have an intro. It's really boring. I'm like, hey guys, this is the start of a new series where I teach you about the server and client model. And then we just go into delete instances, which is like, who really cares about that? Like, we want to get into the interesting stuff, the applicable stuff with tools, but you got to sit through like 26 minutes of just stuff before we get into tools. So I think the way I started my advanced scripting tutorial guide could have been executed a lot better. Like, I could have had a funny intro with like, young little Newbert finally understands the basics of Roblox scripting and wants to make a game on Roblox. And then something along the lines of like, he tries to make a game on Roblox until he hits another roadblock trying to figure out what the heck the server and client boundary is supposed to be like. And as a result of that, he quits on day 7 and probably doesn't have his second computer anymore after destroying it out of frustration. And now he can't pursue making the games he wants to make on Roblox. It's the same exact story. That'd be funny. Yeah, well, Dev King superseded Peace Factory. Truly is a cycle. I will say, to anyone who's watching this right now, if you genuinely like the content that I put out and this kind of inspires you to be like the next YouTuber to teach Roblox scripting, good luck trying to trying to supersede me. I think for what I did with the advanced scripting tutorial guide, at least, it was really hard to get all these videos out. So you're gonna have to figure out a way to do something that's even more valuable and something that's even more understandable to an audience that wants to learn Roblox scripting. You're gonna have to supersede me somehow. So I could never. I'm way too awkward on videos. I mean, like, I used to believe that about myself too. Even today, I still consider myself to be an awkward person. Like, literally, five 5 minutes before I started the stream, I was just staring at the go live button because I, I always get nervous before going onto a stream. It's like specifically a stream where I get really nervous compared to a video, and that's probably because on a stream I can say whatever I want. It's unscripted. I have a live audience watching me, so whatever I say, I have immediate feedback on what is happening with whatever I talk about. Whereas a video, if I mess something up, I can just retake the same part of the video. And I can also edit it out too, so I don't sound as bad, you know? Newbert will make a front page game one day. Yeah, that's right. You guys are Newbert, all right? I don't think I have a Newbert model inside of this place here. This is one of my older versions of the advanced scripting guide place. Newbert will make a 100,000 player game. Yeah, I'm sure he will. Okay, that's what it's all about. Will we ever get more in-depth videos of other aspects of development besides scripting? For example, animating, GUI, etc. I do have a playlist for GUI. Now, some of you might be asking what happened to the GUI tutorial guide, because I think the last video I uploaded on there was like 6 months ago, I think. GUI tutorial guide. So, yeah, GUI tutorial guide. The last episode, 9 months ago. That's actually a lot longer than I thought. Damn, I thought it was like 6 months, but 9 months is crazy. Anyways, you might be wondering what happens to the GUI tutorial guide. So, on the playlist, I have more videos that I had planned, but I never came back to it because, first of all, the views are low. Like, nobody, like, at least compared to the beginner scripting guide and GUI tutorial guide, not a lot of people are really interested in knowing about how certain GUI elements work, unless it's like the very basics, like screen GUIs, text labels, text buttons. You can kind of just figure out the rest of your stuff, or figure out the rest of the stuff on your own. Like, all these GUI elements, these are objects, or these are instances that are created by Roblox. Here are some properties, here are some methods. You can tinker around with them, and that's basically all you need. Now, there are some concepts that are pretty complicated in the GUI tutorial guide, like viewport frames, absolute positions, or absolute properties in general. I think some people do get pretty confused about that. And then just general concepts in the realm of GUIs. Honestly, I'm not really a fan of working with GUIs. I think it's really boring in my opinion. But if you want to know what the next episode of this guide was supposed to be, it was supposed to be about absolute properties, but when I tried researching it, it was just so boring to research, and also it's a topic that nobody would probably be interested in talking about anyways, or learning about. And if I were to continue with the GUI tutorial guide, it would be filled with many concepts that people wouldn't really seem to care to know about or be interested in, so I just don't think it was really worth it. So that's kind of why, as of right now, the GUI tutorial guide is on hiatus, or I don't really plan on coming back to the series anytime soon. But that's kind of my take on the GUI tutorial guide. That's why there hasn't been a new episode in like 9 months. I just don't really see a reason to come back to it. Have you seen the new input action that's in beta? It allows for keybinds. I have seen it, and I think it's going to make my input action service and context action service episodes obsolete, because the new input action service stuff is going to supersede it. It's going to make it better. I did think it was really cool. I saw a video on it. It's so easy to keybind like controller buttons to the keyboard. I saw someone do it in like one line of code. It was so simple. But yeah, like every time Roblox pushes out new updates, more and more episodes of the advanced scripting tutorial guide would just become obsolete. There's nothing I can do about that. That's just how tutorials are. The only way for me to fix that is by recreating new tutorials. But that's not something I plan to do soon, so. Oh, you guys are asking about Raycast. I know that. It's been one of the most requested episodes on the channel. okay, if you want to know, going back to this number 3, there's 3 episodes left in the advanced scripting tutorial guide. If you want to know if raycasting is going to be in there, I will tell you right now. Yes. It's going to be one of the last 3 episodes, don't worry. Everyone hears from the Discord. I mean, yeah, that's fair. But yeah. Yeah. It's been a long time coming. The advanced script, I mean, what is it? The raycasting tutorial that I've pushed off for the longest time will be one of the last 3 episodes, so don't worry about that. We've been waiting 9 years for it. Yep. That's insane. All right. We got about 22 viewers in here, so we're about 26 minutes into the stream. I think this is a good place to start doing what we were supposed to do on the stream, which is learn physics. So I'm gonna be honest, when it comes to game development, I've kind of avoided physics for the longest time, just because I think physics it's one of those things I just don't find to be very interesting at all. I just think it can get really confusing a lot of the time. And I'm just not a math guy too. Like, if you were to look at any sciences, I think physics is one of those sciences that require the most amount of math compared to any other sciences. And because I'm not a math guy, I'm not really interested in physics. But I know for game development, physics is a very big thing that you have to know about. So that's what we're going to be doing in this stream. We're going to be learning some stuff when it comes to physical constraints. I think physical movers is another one of them. We might get into physics service, or like collision groups. We might go into that as well, but probably won't be able to go through everything inside of this stream. I just want to go over the ones that I'm going to be talking about on a future tutorial that has to do with physics. So let's go ahead and get started. So I want to first talk about what physics is. So it's, as I mentioned before, physics is it's a type of science where we study how things interact with the world through kinetic energy and other things like that. Now, from what you learn in high school, which I'm guessing that's where you learn, that's like where you first get introduced to physics, they present to you with all of these boring illustrations and all of these vectors and calculations and formulas and all that sort of stuff, which is why I'm definitely not a fan of physics, but it is one of those things where you kind of just have to suck it up and go through it with learning it, because it's very vital to game development. It's very important to know about. Physics equals lag on the server. To be honest, it's mostly Newtonian physics, which is infinitely more manageable than whatever quantum mechanics is. I don't know much about quantum mechanics nor Newtonian physics. I just know general physics, because I took an honors physics class in high school, and I also took like a slightly more advanced physics class in college as well. So I'm still not the biggest guy when it comes to knowing how physics work. But Roblox, fun fact, if you didn't know, Roblox used to be a physics engine. So if we were to look at Roblox physics engine 1990 or something, I don't know if we're gonna find results on it, but Roblox used to be solely just a physics engine for students to be able to use to create cool stuff. So this is one of the most famous examples here. So this was called interactive physics, and literally all this is what Roblox used to be. It was just a physics engine. You would have characters that could move around. You would have objects that would interact with other objects to create really cool effects and all that stuff. And if you didn't know that, I just thought this was a pretty interesting thing to know about. This is what Roblox used to be. It was just a physics engine. I recommended placing 10,000 unanchored physics parts for the best optimization in your game. If you were to tell anyone that, I don't know who would believe it. 10,000 just sounds like a really big number. And especially when you have unanchored parts, you have Roblox's physics engine that has to calculate gravity for all those parts. So if we were to think about how this would play out in game, let's just let's create a simple script. What I'm going to do is create a while true do statement with a task.wait for about 0.01 seconds. What I'm going to do is create an instance. So local part equals instance.new part. We're gonna put this inside the workspace. And I know you're not supposed to put the parent to the workspace in the parameters, but I don't care. This is just an example. So then I'm going to put part dot. I believe parts are unanchored by default. So I'm just going to say part dot position equals vector3.new. I'm just gonna say 0, 500, 0. It's like somewhere around there. Let's just see what happens if we were to run the game right here. Yeah, so here are all these parts that are just, oh my god, exploding. Do you see all these parts, bro? But yeah, give it some time, and it's gonna start to lag the game like crazy. You can already, like, I don't know if you can tell, but my studio is starting to lag just a little bit. But essentially what's happening here is when we insert all these parts inside of the game, Roblox's physics engine has to calculate the gravity for each part. And when you calculate gravity, it can be very expensive when you have so many parts that are going to be calculating it at the same time. And if one of you guys in the stream are saying that this is a really efficient way to, I don't know, optimize your game by adding 10,000 parts in it, you're a fool. Yeah, this is, yeah, you can start to see it's really lagging now. But that's the whole idea. That's the whole idea. You're just letting Roblox calculate everything. And there's also a way to pull up, there was a way to pull up the performance. I forgot what the keybind was specifically. It was to bring out the micro profiler. Wait, if you guys remember what the keybind or the what is it, the shortcut is to open up the micro profiler, let me know. I kind of forgot. But yeah, if you gave it some time, oh yeah, and as you can see, some parts are literally freezing because it's just really slow right now. Alt F4? Oh, okay. Alt F. Oh wait, that just saves changes. I don't know if that's exactly correct, or maybe I have to be inside Studio. I have no idea. Alt F4. Okay, well. Anyways, I haven't really made a video on microprofilers, so a couple of you guys in the stream have probably used this before, but it essentially measures the performance of all the resources that are being used inside of a Roblox game. Okay, you guys are you guys are trolling. You guys are giving me all sorts of weird nonsense. Oh my god, this is embarrassing. I've been a developer for so long. How did I forget how to turn on microprofiler? Using a shortcut, anyways. But yeah, so basically physics is being applied to every part, and that affects performance. So that's why it's really important to know how to optimize certain parts of your game, especially when you're adding a bunch of instances that require the use of gravity or any other physical changes to any instance inside the game. T, how's it going? Yeah, T, I saw your I think it was like Crate Mania or something. Sorry, I forgot what the name of your game is, but like a lot of developers give up on whatever game idea they have after like the first month. And I know you've been working on that game for a long time, so because you're still working on it, huge props to you. That's very impressive. And I'm going to say good luck with the rest of your game. If you do end up finishing it by this year or next year, I'll be down to play it. But yeah. Yeah, Crate Hunters, that's what it's called. Yeah, yeah. I knew it was something. It started with like a crate, and then it was like an H something. I forgot exactly what it was, but yeah. Yo, guys, stop giving me these weird shortcuts. You guys are probably gonna break my stream if I actually try any of them. I can't trust you guys. Okay. So in my scripting tutorial guides on YouTube, I've taught you guys how certain properties work that involve the use of physics. So there are certain things like anchored. Anchored is like the easiest. It's like the most commonly used physical property that any Roblox developer can use. So basically, anchored is like if it's anchored and if you run the game, then it's not going to be affected by gravity. And this is actually good for performance because the less instances you have that involve gravity or any sort of physical movement or change, the better. But by default, it does use Roblox's gravity. So Roblox's gravity calculates where it should be in the game, just like that. And then there are some other properties here. So there are some other, yeah, there are other things here, like custom physical properties. There's the mass. You can set something called massless. So it says it determines whether the part contributes to the total mass or inertia of its rigid body. If you do those button combos, your stream is gonna blow up. Yeah, which is why I'm not gonna trust them. Okay, let's look into a few things. There are some pretty nice tutorials in the Creator Hub that talk about physics, or at least the overview of physics. So you have things called assemblies, then we have constraints. If I were to make a tutorial on physics, I would definitely talk about constraints. So you have mechanical constraints that offers things like hinges, springs, ropes that can be used to build mechanisms. One thing that I want to give props to Roblox for is that you actually don't need scripting knowledge to be able to create some of these really cool physical projects or concepts or builds inside of your Roblox game. You can just use instances and properties to achieve whatever thing that you're trying to build using physics. I think that's really cool from Roblox, but obviously if I were to make a tutorial, I would want to focus on the scripting part while also somehow giving an introduction to these instances at the same time. Oh, what does massless do? Does it make the part massless? No way. I would have had no idea. What would that actually do, though? So if we hit run, it's still going to be affected by gravity. I remember using massless before, but I don't really use physical properties that much, especially the ones that are less frequently used. So I just have to sort of just experiment and figure it out. But yeah, when you're thinking of physics on Roblox, you probably are thinking about mechanical mover constraints. You're probably thinking about how can you use these to create cool mechanisms like this trampoline here. It's not a very effective trampoline, but like it's something that uses springs. There's many famous examples of using physics to create cool mechanisms inside of your Roblox game. So why don't we just go through them one by one? I think mover constraints would probably be easier to talk about. So it's as I mentioned before, physics is the study of how objects interact with the world using kinematic energy and other things. So if we were to have this part that were to, I don't know, let's say move along inside of one direction, or move along inside of different directions, or even have some rotational direction as well, through Roblox's runtime. So while the game is running, we would be able to do this using these physical movers. Now, if you're thinking about like body velocity, body movers, those are actually deprecated. So Roblox wants you to use mechanical constraints and mover constraints because those are better, supposedly, and these are more up to date. So if you see games or tutorials online that use body movers, body velocity, things like that, those instances are deprecated. Instead, you want to opt for mover constraints or mechanical constraints. Body velocity is still good, but usually it's not a very good practice to use something that Roblox deems to be deprecated. Papa Brawl teaching physics to Noobert. All of you guys are the embodiment of Noobert. That is correct. So yeah, if we look at the basic definition of mover constraints, we're going to start with this first. So mover constraints apply force or torque to move one or more assemblies. Now, if we were to look at the definition of assemblies, an assembly is one or more parts connected by rigid constraints or motors, and they can be used to they can be set to an initial linear or angular velocity, or their behavior can be affected through constraints. So an assembly is basically a certain property inside of a part or a model that is able to be modified to apply physics to this part or this model. That's kind of like what the whole idea is with that. So every single part or instance has this thing built in, usually. It has at least one assembly, and that's how it works. So mover constraints, if we were to look at this video, Roblox does have really cool videos when it comes to showcasing all these different movers and all these different constraints. So we're just gonna go through some of them, just to give you an idea of how we can manipulate parts inside of a game. So if we go to mover constraints, we have some really popular ones that a lot of developers use, but also some not so popular ones that developers don't really use that much. Oh, and by the way, so if you don't have constraint visualization, that would be really helpful to show us what kind of constraints and movers that we are using for some of these parts. Oh my god, spin! It's a Joji gyro reference. I don't know what you're trying to say. It's a JoJo reference. Yeah, anything that's spinning is a JoJo reference. That sounds about right. Okay, I know some of the most popular ones that people use are linear velocity. So let's take a look at that. If we were to have this part here, there's two ways you can do this. Two ways you can add movers. So one way to do it is by going to model. Then there should be, yeah, so in constraints, there's a drop down here, and you can add a constraint. So let's say we wanted to add, what was it, linear velocity? I think that's what it was. So if we were to add a linear velocity there, yeah, then what's going to happen is this part is going to be met with two instances. So first thing is the attachment, and second thing is the linear velocity. So linear velocity, all it's doing is it applies force on an assembly to maintain a constant velocity along a certain space. So it can be a 3D vector, it can be a line, or a 2D plane. So if we were to think of a line is basically just one axis that looks like this. So just think of one of these axes as a line. That's basically what it is. And then a plane is two axes. So let's say if we want to combine X and Z, these are what you'd call planes. It's when it's two parts of the vector 3 instance, basically, or the coordinates. And then if you were to think of a 3D vector, it's essentially just combining all three of them together. So you have X, Y, Z. So the easiest way to think about is a line is one vector. Two vectors is a plane, and then three vectors is a 3D vector. Or in this case, a vector 3. Because a vector 3 consists of three vectors. And a vector is when you have a starting point that goes inside of one direction. That's basically what it is. But now going into the whole thing about linear velocity and the attachment that was created. So you need to have an attachment before you can use a constraint. because you need to have a specific place that you want this mover to be in. If we were to just have linear velocity, we can't specify where we want the mover to be. Like, it can't just be inside the part. We need to have an attachment. So if you want to know how to add a constraint without using this dropdown, what you would need to do is you would click on the plus sign on part, then you would search up an attachment. Now this attachment can be anywhere in the part, as long as you have an attachment somewhere in the part. And then inside that part, we're going to create the constraint that we want, so linear velocity. And what we need to make sure that we do is we need to set the property of attachment 0, and we want to link that to our attachment that we just created. And so once we have that, then we need to specify a vector velocity. So we want to apply a constant velocity to a specific direction. So there's 3 numbers here, x, y, and z. We want to pick a direction that we want the velocity to go in. So if you want to make it go inside of x, I'm actually going to make the selector visible. If you want to make it go towards this direction, then we're going to change the x property. So vector velocity, let's change this to, let's say 1,000. And you usually want to work with big numbers, because if you have numbers that are too small, then you're not really going to be seeing a difference when you do that. And as you saw, when I changed the vector velocity to go in one direction, so I set x to 1,000, it's now pointing an arrow to go that way. And I believe that's all you need to do to see an immediate effect. So if we hit run, then I think what we should see is, look at that, it's just sliding on down there. Except there are some objects in the way, like this button and that little speeding wall thing back there. And some people actually get confused about the difference between some properties that are exactly the same. So there is linear velocity, then there's something called what was it called? It's called no wait, I forgot what it was called. What was it called? It was called something. So there was linear velocity, then there was assembly linear velocity, and then there was something else. I forgot what it was exactly. Was it inside of mechanical constraints? I have no idea. I don't think it was. I don't know. I must have forgotten, but that's why we're researching. Yeah, we have different properties here that talk about velocity constraint mode. So we can make this into a vector, or we can restrict it to a line or a plane. And as you remembered when I told you before, a line is basically 1 vector, a plane is 2 vectors, and a vector is you can think of it as like 3, like a vector 3 kind of deal. Now, if we wanted to change this to a different direction, so if we were to do 1,000 on the x and 1,000 on the y, then it's going to try to go up. But because gravity is being affected, we can't really see this go up. So we would have to, this would not really work. But instead what we can do is do 1,000 on the x and 1,000 on the z. So it would go in this direction. So if you hit run, then it's now going to apply velocity in that direction. Now, one thing you might notice too is the point of velocity is that you want to start small, and then you want to keep applying like a force to make this part go inside of one direction. And it kind of like multiplies. So when you start, it's very slow, but then it progressively gets faster and faster the more you let it go in a certain direction, because you're applying constant velocity. That's the whole point of what linear is. You want to apply velocity that's consistently going to go inside of one direction or place you want to specify. So if we were to hit run here, it's going slightly faster and faster and faster. It's not noticeable, but it's slightly faster. So if you're able to understand linear velocity, then you will have an easier time learning about some of the other ones. There are some other properties here, like force limit mode. So this one either uses magnitude or per axis. So in my pathfinding video, I talked about what magnitude is in the context of pathfinding. It's basically the distance between one point and another point. It's kind of what it is. Oh, and then there's other modes that describe what these forces are relative to. So if it's relative to the world, I think an easy explanation for this would be if I were to have a part here. So if we want to have coordinates that are relative to the world, or in this case, it's global, then it's going to look like this. You're going to have the z-axis here, the x-axis here, the y-axis here, and if you rotate it, it's still going to be relative to the world and not anything else. But if we were to make this local, the shortcut for this is Control L, then it's going to change the local axis, or the local, what is it? Yeah, the local axes of this. So now I'm switching between local and global, and you can tell because there's an L right here. So right now I rotated it in its local version of its axis. So this can be easier to work with sometimes if you want to have precise rotational or positional change based on the part itself rather than the world. Or we can change it to be global so it looks like this. So what I'm trying to get at here is that's what this is supposed to be with what it's relative to. So it's either relative to the world, which is global, or we can make it relative to the attachment. So this attachment here. And this actually does make a difference if we were to change it to, instead of being it relative to the world, we're going to make it relative to attachment 0. And now what we're going to do is hit test and hit play. In certain instances, it does change, but it looks like it here it's not. It like really depends. Yeah, if we were to look at something else, linear or angular velocity in this case, we can think of angular velocity as like the rotational counterpart to linear velocity. Oh, and by the way, I forgot to like present these videos here, which kind of describe these very well. It applies force on an assembly to maintain a constant velocity, so that is constant. Now, earlier when I was explaining how it like starts slow, but then it gets progressively faster and faster, I think that's actually incorrect. So I think I got it wrong there, because linear, the point of linear is supposed to be that it's maintaining a constant velocity or movement or rotation or whatever physical change we have to a part. It's always the same. It's never going to change. I was thinking of something else. I might be able to find that later. Now, if we were to look at something like angular velocity, this applies what's called torque. Now, if you guys know what torque is, it's sort of like a rotational property when you're rotating something. It's kind of like how hard you have to pull or push something to have like a rotational goal. I think I kind of butchered that a little bit. If we were to search up like what is torque in physics, there's a definition for it. This should be like really easy. This is like a really simple definition. I don't know how I don't know this, but it's the rotational analog of linear force. So it's also referred to as the movement of force. So it is sort of like how I described it earlier a little bit. But yeah, you can kind of think of it as like, this is how much force I need to apply to rotate a part. That's basically what torque is. I just hope I'm not butchering that. Are you guys finding the stream to be interesting? Are you guys like learning something, or is there like anything specific you guys wanted to learn about physics that's maybe not too complicated to implement or talk about? I could talk about something if I know about it, but just to let you guys know, this video is about physics, and physics is a very broad topic. I'm just trying to get the physics brain going so that I'm able to make a tutorial that's based on this stuff. Modeling tutorial. I unfortunately am not an amazing modeler on Roblox, so I'm probably not the guy you want to look for when it comes to modeling. But yeah. It's Nail here. Hello, how are you doing? Okay, so now if we were to work with angular velocity, let's look at this. Angular velocity, we're going to set the same attachment here, and we want to make sure linear velocity is disabled. So angular velocity, let's set it to be, let's say 100 on Y. And then max torque, let's set that to 1,000. And we want to make it relative to the world. And if we hit run, then we should see that this is, it actually is spinning really fast. Is it moving along any certain axis? I don't think it is. I think it's stationary for the most part. But it is sort of just rotating like that. And then if we were to change, let's say, the Z, I don't know if this would even work because Roblox is the parts being affected by gravity, so I don't even know if that is. Oh wait, never mind, it's working. It's like a what is it? An ice hockey puck. Oh, that's funny. It's kind of just like zooming out. JoJo reference again. Yeah, that's right. You can do some pretty cool stuff with this. Max torque, if we were to set this back to 0, let's see if that affects anything. So it does affect it. You have to have a limit to how much torque you can apply. And if it's 0, then you can't rotate it at all. I don't know why I even asked that question. That should be really easy. Or that should be really simple. Now, what I want to do is let's see what happens if we change it relative to the attachment and see if that changes anything. So if you hit run, what's interesting is it's actually not rotating at all. But if we were to make it relative to the world again and hit run, oh wait, never mind, I broke something. Is it because I set max torque to 100? That could be why. If we were to hit play really quick, there we go. Okay, let's try that again with attachment 0. It looks like it's kind of doing the same thing. So I think the relative to property is used for very specific occasions. Yeah. I watched your video on the basics for scripting. It helped me a lot, so thanks. You are very welcome. Good luck going through the advanced scripting tutorial guide. You're going to be sitting through like, I think like 15 hours of content. So, I mean, you can get through that, then that would be very impressive. So yeah, angular velocity, it's the counterpart to linear velocity, except it adds rotational value instead of positional value to a part. I'm going through this really slow though. Like really slow. We also have things like align position and align orientation, so I think I can make this go a little faster. Align position applies force to move 2 attachments together, or to move 1 attachment to a goal position. Okay. So this one requires 2 attachments, from what I can tell. Now, the reason this example uses 2 parts is because what we're interested in is we want one attachment to reach a certain goal to a different attachment, and that attachment could be attached to a part. The reason we use parts is because we can see it visually. Whereas if we just use an attachment, we can't really see it that well, or we're not really interested in doing it that way. So that's why we want to use parts to use for this example. So let's see what happens if we were to create another part. I'm going to have the attachment here still. I'm going to rename this to attachment 0 and attachment 1, just so that we can see which attachment we're looking at. I'm also going to add, what is this called? An align position. And this is a 2 attachment mode that we're going to be using. So we need to apply attachment 0, which is this one, and then attachment 1, which is this one. So now you see that there's an align position that's connecting these 2 attachments together in their associated parts. Now it looks like we're getting a warning here. So it says, what does that say? Reaction force enabled is false. It's unphysical as the constraints only applies force to the first body but doesn't apply an opposition force. This can lead to unlimited gains in energy. So I think what this is trying to say here is both of these parts are working with physics. So I think we need to make one of them anchored and make the other one not anchored. So if we were to look at the align position, no, the warning's still there. Okay, it looks like the warning is still... I don't know what that warning's all about, if anyone knows, but... DJ Nikes! How's it going? Glad you can tune into the stream. So are you learning or are you teaching us? It's kind of a bit of... It's a bit of both. I'm relearning physics while also explaining what I know about physics. In case you guys don't know about certain things. So it's kind of like both. But let's see. Align position, applied center of mass, rigidity enabled. There's a lot of properties here. Okay, let's hit run. And what should happen is this attachment 0, because we're into attachment mode, we want to make this match the position of this attachment that's inside of attachment 1. So if I were to change this, then it's just going to try and follow the attachment. So you might be thinking in your head, this kind of looks similar to a pet if it was following you. And you're right, that's actually a really popular use case of using align position. It's to match the position of one part to another part, or a goal in particular. So that's the whole idea behind this. And if you were to combine this with align orientation, this can also affect the orientation of one part or one attachment to match another one. So that's why it's called align, because we are aligning one attachment to match another one. Or like either another attachment or a specific goal for like a vector, whether that's like an orientation or a position. But usually it's matching an attachment to another attachment. So I'm just going to disable align position, and I'm going to create an align orientation. I'm going to make attachment 0, attachment 1, attachment 1. And then what should happen here is if we were to hit run, then it's going to try to match the alignment of the second part. So as you can see, that's what this part is doing here. Now you do want to be a little careful. If you're just using align orientation and the part is unanchored, then it's going to shift around a little bit, as you can see right here. That's what it's going to be doing. But if you were to combine align orientation and align position, then you'll get some interesting results. Although you might not want to make the position be here specifically. What you could do is sort of move it out here a little bit. So I'm going to make sure align position's enabled, and so is align orientation. So now, oh, that's a little close. Hold on, I'm going to make this farther apart like this. That's where attachment 1 is, so it's going to look like this. Now, if we were to move it like this, then it's going to follow the second part just like so. And even if we were to rotate it as well, it's going to try and follow it. I'm cooking here. I don't know what you guys think, but you can kind of imagine this to be like a pet if you were to play like any simulator that has pets in them. It's kind of how you'd imagine it. It would look something like this. And the position is not, like the position or orientation is not hard-coded or rotated or anything. It's doing it very smoothly because that's the whole point of body movers. And this is how you apply physics to something like that. I might make a game called Have a Pet Brick. I mean, that'd be a very basic game to make, but I mean, you could totally do that. But yeah, so if you combine align position and align orientation, you can make some cool stuff with that. Now, there are some properties here as well. Like, apply at center of mass. So apply at center of mass means like all the mass for the part that is going to be changed is at the center rather than like where the attachment is. So basically, if we want to apply at the center of mass, then we want to utilize the center of the part rather than where the attachment is specifically. If you were to work with that. Reaction force enabled, or no, really, I think an interesting property here would be... Hold on. So there is still a warning here. Reaction force enabled is false. So it's unphysical as the constraints only apply a force on the first body, but doesn't apply an opposite force on the second. Line position will try to bring the two attachments into the same location. So let's try enabling reaction force enabled and see what happens. And I'm gonna disable align orientation. Let's see what happens if we do this. Doesn't really seem like it changed much. Let's set the position back to here. So if we were to have this, it's still going to follow it. I don't really know what changed though. I don't really see it. I am back from dinner. What did I miss? You did not really miss much. I talked about what was it? Align position and align orientation. Attach it to the player. If I were to use align position and align attachment, that would be useful to have on the player. I don't really know what this is, but I do know what rigidity enabled? I know what this is for. So when you use physics, it takes into account gravity and other properties that will sort of translate where it started to where it ends. So that's what happens when you try to move a part from one position to another, and it takes like a little bit of time to do that. But if you enable rigidity, it kind of does that instantaneously. As you just saw right there. So, whoa. It's kind of like messing up the camera there. But when you see rigidity is enabled, it's going to try and immediately reach its goal without waiting for any time to just make its way over to the goal, if that makes sense. But with rigidity enabled, this is kind of like really fast. Are we going to make a video about this, or is this just going to be live? I was intentionally going to make this into a video, but researching it is a little tough, so that's why I'm doing a stream to hopefully try and make it easier to explain. Or make it easier for me to understand, at least. So yeah, rigidity is pretty cool. Force limit mode, max force, max velocity. Responsiveness is 10. So responsiveness is sort of like how fast it would take for the part to be able to reach its goal. That's the whole idea behind it. Oh, vector force. This might be what I was thinking of earlier. So you have linear velocity, then you have vector force, and then there was that other property that I showed before. That other property being assembly linear velocity, which I think I'll go into that as well later. So vector force applies constant linear force on an assembly, which is different from linear velocity. I know this is different. So if we were to add a vector force to this part, set the attachment to this, and we're going to apply a force that goes in this direction, and this is going to be relative to attachment 0. But let's make it relative to the world for right now. So if we were to hit run on this... Oh, hold on, I have to disable align position. Got to make sure that's not enabled. Now let's hit run. So that is where it's going faster and faster. Oh, it just went through that part. That's really interesting. But yes, what I was confused about before was the difference between linear velocity and vector force. I was mixing up the definitions with linear velocity and vector force. So linear velocity applies a certain velocity that goes from one direction, that goes inside of like one direction or multiple directions. But it does this consistently and it doesn't change at all. But if we were to use a vector force, this is what I was talking about before, where it starts slow, but then as it consistently applies more and more velocity, that's when it just goes faster and faster and faster as long as it is still enabled. Or until it reaches like a limit that we put. So if I were to make the force go 1000, let's make it 100 on the X, 100 on the Z, so it's going to go in this direction. What I'm going to do is I'm going to duplicate this so that we can see in real time what's happening if we were to have linear velocity and vector force. So linear velocity, I'm going to make this 0. Vector force. Yeah, okay. So this is vector force. This is linear velocity. But it's not enabled. Now it's enabled. Okay. So let's see what happens if we hit run on both of these. This one did not work. Why did it not work? Vector force. Let's make it relative. Oh yeah, this is relative to the world. Maybe I need to make the force 1000. Let's try this now. So now both of them are moving. And there we go. We are now starting to see a difference here. So it's as I said, vector force starts slow, but then it goes really fast. But this applies a constant force. It doesn't go any faster than where it started. So if I were to like race with these two parts here, this is the vector force, this is the linear velocity. If we were to hit run, then what's going to happen is they're just going to be racing on just like that, and vector force wins. If this was a race, at least. But yeah. That's what I got confused about, but now that confusion is cleared up. I'm just gonna delete this. Don't want this. Vector force. Yeah, all these properties should be fine. Disable this. It's gotta be 1000, because 100 is not enough. Right now I'm watching your episode of Roblox Advanced Scripting. That is good to hear. Good luck with going through all the episodes, or at least the episodes that you don't know how to do. Torque applies constant torque on an assembly from its center of mass. That should be pretty easy to use. It's basically just applying a constant rotation to a part. That's literally all it is. It's just applying a constant rotation to a part. So yeah, just like that, that's what it does. Align force, it applies force along the theoretical line connecting its two attachments. So it's applying force on the line that is connected with the two. That's really weird. That's like a very specific use case of it. I'm not gonna lie. Don't really know. Oh, but yeah, I think at least those are the important ones to know about for mover constraints. So I don't know if you guys have any questions about mover constraints, but it's probably gonna be a good time to move on to mechanical constraints, because there are more mechanical constraints than anything else. We can use torque while making car wheels. I think from what I've seen, you can use torque to make car wheels move. That is pretty advanced, but yeah. I think that's what you can do, but when you're using cars, I don't think you want to use torque to make the car wheels move. Instead, what you want to do is make it so that when you're driving, the wheels are attached to the car, and you just let Roblox's physics move the wheels by itself. I don't think you need to use torque for that specific case, if that makes sense. Those wordings are a bit confusing for line force, so it applies force to the theoretical line connecting its two attachments. I think, yeah, this one I don't really understand too much, or when this would be used. It seems like it's very specific, but yeah. All right, I think that's a good introduction to mover constraints. Let's move on to mechanical. This is going to be, I mean, if you really think about it, these are just physical objects that you can just add to your game to make cool systems. If you understand examples of using each of these objects, then they should not be too difficult to use. And it kind of is just all about experimentation, really. And when you're a Roblox developer, you might not even use all these constraints either. So if we were to look at constraints, the basic definition is that they are used as conceptual mechanical connections. So these are things like hinges, springs, ropes, and more things like that. So if I were to look at this list and tell you some really popular use cases for these constraints, ball socket. This is very practical for ragdolls, and the reason that it's very practical for ragdolls is let me show you really quick. So I'm gonna load into the game with my character, and let's say a few words before I go bye. Thank you for watching all my tutorials on my YouTube channel, but I think it is time for me to go. So goodbye, world, and I'm just gonna reset my character. There we go. We got ragdolls. So instead of exploding my parts into a million pieces, which is how it usually is for normal Roblox games, you can attach ball sockets, which what it does is it forces two of its attachments to the same position and allows them to freely rotate about 3 axes, with optional limits to restrict both of them. So you see what's happening here with this ball socket is it's staying in the same position, but the rotation or the orientation of both of those parts are using physics to change its rotation while maintaining the same position. And that's basically what it is. That's what ball sockets are. So when you reset your character is made up of like 15 parts, and when we attach a ball socket to each connecting part, then it's going to create this ragdoll effect. So if we were to reset my character again, it's all connected, and it kind of just like swings around like that until I just like, you know, respawn again. That's the whole idea behind it. Well, let me show you the script behind it. So when the character dies, first thing we want to do is break joints on death. And this is important because we don't want to make the parts explode when the character dies. So we want to make sure that the breaks are not, or we want to make sure the joints are not broken when they die. And when we loop through all the parts inside the character, we want to make sure that there is not a motor 6, or we want to make sure there is a motor 6, which is, if I were to look up the definition of what is a motor 6 in Roblox, it's basically like a weld that can be, wait, is it like a weld? How do you call it? It's an object that joins two parts together in an animatable way that allows for movements and rotation between parts. So motor 6 is very popular in the animation space, also with inverse kinematics and all of that stuff. It's really popular when it comes to that. Break joints on death. My roommates are is gonna question me. Bro, they should have been asking, like, what the heck wait for child is supposed to be, or find first child when you first start creating games on Roblox. That's the first thing they should be asking, not break joints on death. But yeah, as you see, what's happening here is we create an attachment for each motor, which is basically like something that's a part of each part of the body inside the player. And then like what we do here is with this ball socket constraint, we attach it, and then we parent it to whatever part that we're currently looking at here with its motor 6. We also want to make sure that the humanoid root part, the little invisible part that kind of acts as the player's torso, is not collidable. Now you might be wondering what's happening here with this if statement, like if v.name equals neck. We want to use a weld constraint for the neck instead of putting a ball socket constraint on the neck. And the reason we want to do that is because it's going to create like a really weird effect when the player dies, where the head is just like wobbling around, and because the camera is attached to the player's head, the camera is going to be shaking all around, so it's going to look really weird. So if I were to show you what this looks like without all this code here to check for the neck, if we don't ignore the neck and we put a ball socket constraint, then what's going to happen is, look at that, the head is like wobbling all weird. I can increase the respawn time because I think 2 seconds is really slow. But you saw what happened there, right? So if we reset our character, the head is like flopping all around and it's messing up the camera. So the motor 6 that's attached between the head and the torso, we want to use a weld constraint instead of using a ball socket, because that can be really annoying. So it's just a simple detection. If there's a neck, then we want to use a weld constraint, attach the head to the torso. Otherwise, we want to use a ball socket with the attachments that we created. And that's basically your entire ragdoll script. It uses ball sockets. All right, but now if we were to go to something like Hinge, Hinge is used to allow two attachments to rotate about one axis with optional assigned power for motor or servo behavior. Now, what this is saying, well, actually, let me tell you a really popular use case for hinges. Doors use hinges to basically have like a part. It's like the part of the door where like that part is stationary, but then you have the door itself, which kind of like flings open if you needed to. So it adds rotational value to a part that is attached to the stationary part. So that's the idea of a hinge constraint, and one of the most popular examples is creating a door. So it's going to look something like this. And then if we were to look at other examples, prismatic allows two attachments to slide along one axis but not rotate. So this is useful for sliding doors and elevator platforms. So this is really useful. Yeah, if we want to slide an attachment along one axis but not have the ability for it to rotate. So if we were to have like if I were to just go to the toolbox, just have like I don't know, some elevator here. Is this a doors elevator? Oh, it looks like a doors elevator. Anyways, so yeah, have an elevator. We would probably use a prismatic constraint to make it so that you can only move up and down inside of one direction without applying any sort of rotation to it. But this is only if we're applying physics to it. So you can have like a combination of a, let's say, prismatic constraint plus a or one of these objects here. So we can either have like we can probably have a linear velocity, or you could even use tween service. I'm not gonna lie, you could also use tween service to apply the same effect too. It's kind of the whole idea behind that. Cylindrical, it allows its attachments to slide along one axis and rotate on another. So cylindrical, I think, is the same thing as prismatic, except prismatic only changes the physical position when it slides from one position to the next, but cylindrical only applies like a physical rotation that only goes along one axis, while also being able to apply linear power. So this one's moving up and down at the same time as it's rotating along one direction. It's a really specific use case, but you can do that. And then you have things like springs. So with this example that I was creating with this trampoline earlier, it's a really scuffed trampoline. You can even make trampolines without springs, but there are some use cases where you can use springs to create cool systems. Definitely isn't this, though. This is not the best system. So there are videos that showcase how the spring works. You can have like a little spring effect here. This is really useful for cars. So if you have, let's say, a car, let me just search up like a really basic car. So if I were to have a car here, what you could do is you can add a spring. I've seen this be used a couple times. I think for some car implementations, you can have a wheel that attaches a spring to the, I think it's called the chassis. I don't know exactly what you call it, but it's like the body of the car. And that can be used to create wheels. But there are other ways of implementing wheels inside of a car. That is one way of doing it. Then you have a torsion spring. I don't even know what this is for or when you'd use this. This kind of looks like the same thing as a hinge constraint. Universal rope is pretty easy to understand. It's basically, it prevents two parts from what is it? It prevents two parts from separating. And you kind of have like a rope that applies physics to kind of have this rope effect between one person or another. This is used very often, especially for like those two-player obbies where it's like you have one rope that's attaching one player to the next. That's just like, I don't know why that was the first example that came off the top of my head, but I think we all understand how ropes work. It's pretty easy. And then rod is like the same thing, except it's separated by a defined length rather than a rope that can change lengths. So a rod is like, it's like the rigid version of it. And then a plane, if you remember what plane was in the beginning of this little lecture, a plane is basically moving something along two axes rather than three or one. It's specifically two axes. That's what a plane is. But again, it's a really specific example. Like, it's really specific. Oh yeah, and then this is where things like welds come in. So weld constraints are really popular. So if you were to look at weld constraints, basically what it does is it just takes one part, it glues it onto another part. That's one really easy way to think about how weld constraints work. Then there might be things like, what is this, rigid constraints? So it connects two attachments or bones and ensures they stay in the same relative position. And then you have no collisions, which prevents two parts from colliding with each other. But that's specifically two parts. Between two specific parts, but they still may register collisions with other parts of the world. So that's basically what that is. But yeah. Let's see, we got about 5 viewers in the stream. Are you guys learning a lot, or am I just wasting your guys' time? I think, I'm just trying to do, like, the best research I can so that I can make, like, a cool sort of video that introduces physics to someone who's never used physics inside of Roblox and kind of just wants to tinker around and experiment with it, but also shows some ways you can script it inside of your game as well without showing anything that's too complicated or something that takes a really long time to make. I don't know what you guys think, but it's quite interesting learning. There's definitely stuff that my brain's picking up on. That's good. It's good. At least you guys are learning something and not just wasting time by watching me just tinker around with stuff. But yeah. So let's see. Oh, and there was something I wanted to look at here with custom physical properties too. So yeah, there's custom physical properties, and this is what allows you to create some things like an ice effect if you were to walk on it on, let's say, a specific part here. So we have custom physical properties. Let's enable this, and we have these properties here. So we have something called density, elasticity, elasticity weight, friction, and friction weight. So now you can look up all these definitions of what all of these mean in terms of physics, because these are very essential physics topics. I'm actually going to look at that with you. So what is density in physics? If we were to think of what density actually is, so it's the ratio of a substance's mass to its volume. I don't know if that's like super relevant, but what I do know is if you were to create, let's say, an ice part, then we would want to, I believe, it's either make elasticity very small or it's friction very small. I forgot what it was. It was something. Oh, I want to actually play the game here. I don't know what elasticity really did, so I don't think it's that. What was the property? I forgot what it was. Was it friction? Or maybe it's supposed to be a higher value. I don't know. I forgot how you make ice, but when you change some properties, you are able to create that effect. Unless you guys know. Maybe it's... Let's try making 0.9 and then 0.9 here. Let's see if that does something. Looks like it's not really changing anything. Okay, there's no shame in looking stuff up online for information. How to make ice on Roblox. Make a block with ice physics without a script. You can do this without a script. You definitely can. Set friction to a very low amount. I did do that. So I don't know why it wasn't exactly working. Maybe I have to change the friction weight as well. So 0.01, I'm going to make the friction weight 0.1. Now it's really small. And it still has no effect, which is interesting. I don't know why that is. Is it because it's unanchored? Nah, there's no way. There's no way that would be the case. Yeah, no. Oh, the friction weight has to be... Oh, okay, it has to be like really big then. So friction weight has to be big to make a difference. Friction weight, let's make it 1,000. And then friction has to be really small. Okay, now I'm starting to see an ice effect. There we go. So if the friction is very small, but then the weight of it is amplified, then you start to see a little effect here. Took a little bit of time, but finally it got something to work. But these are some very basic physical properties that you can change. Elasticity, I'm still trying to figure out what these are for. If you want to apply like an immediate force to something, what you can do is add a script, and then you can say script.parent apply impulse. Apply an impulse to the assembly at the assembly center of mass. So if we do this, we're going to add an impulse, which is going to be a new vector 3. So if we were to say like 0, 1,000, and then 0, then what we should see is if we run the game really quick, nothing happens. I think I have to make it bigger. Or I just have to wait till it loads in properly. Or maybe I'm not looking at the right part. Let's put like a task.wait for 1 second. Negative maybe? Okay, nothing's happening. I don't know why. Let's try making this. Oh wait, it's anchored. That's why. Yeah, the part's anchored. Okay, yeah, there we go. So I noticed like something. It was small, but it did change. There we go. Okay, yeah. So I applied like an immediate impulse to that. And then there were some sub methods that were related to apply impulse. There was something like apply angular impulse, and then there's an impulse to the assembly at a specific location. So that's a little something you can do as well. Then I don't really know what else I want to talk about. So if I were to make a tutorial on this, I would want to talk about what is physics, and then there were some properties that we definitely worked with. If we were to have... Oh, okay. I was going to say, if you publish a Roblox game, you can change the default gravity, which I believe if we go inside the workspace, the default gravity is like 196 or something. So the default gravity is 196.2, and we can actually change this to be something different. So if you have lower gravity, then you feel like you're more in space. So it's like when you jump, there's less of an effect of you falling down. Versus if you were in like 0 gravity or something, then like it feels like there's no gravity and you could kind of just float around. That's the whole idea. So we've worked with gravity, the anchored property, custom physical property like density and elasticity, but also Roblox units. They talked about that somewhere here as well, which is a little confusing. So it's Roblox units. So it outlines physical units and how they convert to metric units. I don't think you really have to worry about this too much. I think if you don't really care about doing mathematical calculations, you can just try stuff and see if it works. That's like what being a scripter is all about. You just try stuff and see if it works. Yeah, this is one of the things I don't like about physics. It's just about applying formulas and just knowing how those formulas work and like why they're relevant and stuff. Okay, so I want to give like an overview of mover constraints. So it's when you add 2 parts together, sort of something like that. Linear velocity and angular velocity, I think that's going to be pretty important to talk about. Align position, align orientation, that's also going to be important. Then I want to talk about mechanical constraints, but I don't want to go too technical with it. I don't want to talk about all the mechanical constraints, but I definitely want to talk about some of them that are going to be very useful. If I were to make a tutorial, I would want to talk about the ragdoll system. I think that's pretty easy to talk about. I think also talking about tween service and how that's different with physics. When would you want to use tween service over using physics, and maybe show some inspiration of what you can do with physics, like the pet following player example or something. Unless you guys have ideas of what I should add to like a physics tutorial if I were to make one. Because you can make a one of the examples that I created was a trampoline. You can make a trampoline with springs, but it's not exactly the greatest. Or maybe this is just my implementation and it just looks really ugly. Uh, you can just use movers for something like that for a trampoline. You don't have to use mechanical constraints. I don't know if I want to talk about assembly linear velocity. I definitely want to look into examples, more examples of using scripts for physics, because that's what I want the focus of the tutorial to be. Rather than just applying these instances and changing some properties, I want to make it so that you can actually script some stuff. But again, I don't want to go too technically in depth with it. But at the same time, I want you to be able to understand basic physical constraints and properties and terminologies and stuff. C-frames surely is the worst part of Roblox physics. Yeah, it's like some of the most complicated scripts I see involve scripts that use C-frames, physics, and raycasting, and maybe some other stuff at the same time. But it's usually those three that I see that are pretty difficult to work with. C-frames, physics, and raycasting. If you know how to do all three of them, then you already know more scripting than a lot of other people, because those are some pretty difficult concepts to grasp. Thank God, I will never have to learn physics like I did in high school. College life still sucks sometimes. Yeah, it sure does. At least the college I went to, we didn't need that much physics. Thank God we didn't need that much physics, but yeah. What am I going to talk about in terms of other things that you can script with physics? I'm trying to think of some examples. Unless this is something I can literally search up. Roblox physics. Understanding Roblox physics and their conventions to real units. 1 stud is equal to 1/20th of a... Oh, I did not want to do that. 1/20th of a meter or 5 centimeters. 1 stud equals 1 foot. That is something I wanted to learn for quite a bit. It's like... Or that was something I wondered for a long time. It's like, what is a stud in real life? Because a stud is Roblox's unit of measurement, usually. It's like, if you see what a stud is... Well, okay, I don't think there's any examples of studs here, but I think, like, if you've played Roblox for a while, you know what studs are, but... I should explain linear algebra. No, I should not. I should not explain linear algebra. I don't think you guys need to know linear algebra. Impossible. BrawlDev tries to explain linear algebra impossible challenge. Kionaris, how are you doing? I think you should explain G64. I don't know what G64 is, but I will look that up right here. Graham number. Graham number? It's a large finite number used as an upper bound in Ramsey theory. I've actually never heard of this in my life. What is this supposed to be for? So it's a large number that was defined... It's the maximum possible number... How big is... It's just a really big number, essentially. I've actually never heard of it. I don't know if it's relevant, but Roblox's equivalent number to Graham number is math.huge. Boom. Math.huge right here. That's all you need. I remember when I had to put like some really large number for something when I was working in Roblox games, I would just use like 999999999 across the board. I would just try to make up my own really large number instead of using math.huge. I just didn't know this existed back then when I was a Roblox developer many years ago when I was inexperienced. Teach us permutations. I'd rather not. Okay. BrawlDev math stream. I think I'd rather not. I addressed earlier I'm not a math person, so that wouldn't be fun. Okay, let's try to make moving... Can I make moving objects with physics? Let's try this. I'm trying to think of ideas right now. What can I make with Roblox physics? You can create spinning objects. So if you were to create like a, I don't know, a kill brick part. And then if you were to make an attachment here, if you were to create a angular velocity, set attachment 0 to that, max torque, let's make that 1,000. Let's set the angular velocity to 100. This is a really easy use case for it. So if we were to insert a script.parent.touch :connect function, open and close parentheses, hit, if, let's look for humanoid. So local humanoid equals hit.parent, find first child, humanoid, if humanoid then, humanoid.health is equal to 0. It's a very simple kill brick script. If I were to hit play here, this did not work. The kill script worked, but didn't rotate exactly. I think it's because it's not anchored, maybe? Or no, I think if it was anchored, that would be a problem. Because then angular velocity would not work. It should work, though. Maybe angular velocity was just too small. Let's see. Physics. Mover constraints. Yeah, angular velocity should be right. Max torque, I'll make that 1,000. Should work, but it's not. Let's hit run. Maybe I just need to apply more force. Let's do it. 10,000. Still nothing. Do you plan on making a video for object-oriented programming? Yes. Okay. Angular velocity. Do I think I'll make an advanced C-frame video? Maybe on that paid course. I don't plan to recreate my C-frame videos, so if I were to make a more advanced version, it probably would be on there. That would be my guess. I'm trying to figure out why this is not moving. So it's yeah, so it's used to achieve the target angular velocity. This should work. Don't know why it's not. Let's hit run here. I also want to create a restraint for this as well. So I'm going to make this anchored, then hit run. Okay, if we were to make it anchored, then it just stops working. I would also want to add a constraint to this. So a constraint that would work pretty well for this would be... Oh, you know what? What if I just applied a torque to it? What would be the difference if I were to add a torque here? Attachment 0 is this. Then a torque would be 100. What if I did this? Let's see what happens. Nothing happened. Let's do 1,000. That did not do anything either. Torque relative to attachment 0. Let's make it relative to the world instead. That still did not do anything. It's all about trial and error. Okay, well now it's spinning really fast. Like really, really fast. Okay, so it's either like it doesn't move at all or it just spins really fast. Seems to be the only difference. I think you would have to change some other properties to achieve like a specific effect. All I'm doing is I'm trying to make it so that the part is stationary. So if you apply an angular velocity, it's going to keep spinning, but it's also going to stay in place. So for example, this would be used as like an obstacle kill brick. So it would be spinning around constantly, and it's not going to change its position. It's only going to change its angular velocity. I think there's a simple way of doing this though. So what I can do is align. I could probably put an aligned position here. So this is going to be one attachment. So the position of this... What's the position of this part right now? The position of this part is this. So I'm just going to copy that. Apply position, paste it there. No, I would not want to do it like this though. Because if I were to do it like this... First of all, let's disable this. Angular velocity, I'm setting that to true. Oh, the part's still moving. Never mind. Okay, I guess that did not work. I'm getting kind of stuck here. I don't know, I don't know what I'm going to be showcasing. We're almost 2 hours into the stream, too. That did go by pretty quickly. Is confusing? Yeah, it is pretty confusing. I'll probably have to do more of like my own background research before I continue setting up preparing the video, setting it up, and recording it before everything. Wait, that did not make sense. Okay, yeah. I think... Chat, here's what I think. it would probably be best for me to end the video or not the video, the stream here. And I'm just gonna be doing more of my own research before I can make a video on it. I think that's what it's gonna have to be, but I did enjoy showing you guys my process of researching videos. It is pretty important to, at least I think it's pretty insightful for you guys to see how a video is made. I might make a video in the future. Oh, my spring is messed up. I might make a video in the future talking about what goes behind the scenes when it comes to making a scripting video. And for all you guys who are watching the stream, you kind of are getting a glimpse of what it's like to research a video. But yeah. I love how the most important for most games stuff like movement are the hardest to learn. Yeah. That also makes you more valuable though, because if it was that easy to create stuff like movement systems and all those other sorts of things, then people wouldn't find it nearly as valuable. If you are a scripter who knows how to implement these systems that are really high in demand, then you're pretty much set. Because if it was easy to make, then there would be no point in being hired as a scripter, because someone who doesn't know that much scripting can just implement it. But if you do know, then that's very good. All right, but while I'm wrapping up the stream, I do plan on ending it pretty soon. The stream's gonna end probably at the 2-hour mark. What I want to say is, I'm gonna continue researching this video. This is definitely gonna be a physics-based tutorial that's gonna be coming out in the near future, hopefully by the next 2 weeks, or maybe even next week, depending on how lazy I am. But I'm trying not to be lazy with my channel. My summer break has started. This is the perfect time for me to grind out my channel and release as many great videos as possible. And if you're wondering what I'm going to do after my beginner script, or not my beginners, my advanced scripting tutorial guide, once that's over, I'm gonna branch out to other types of content, maybe have more personality-based content. I definitely want to have more one-off entertainment content. I do want to bring more entertainment content to the channel rather than just educational, but I still want it to be entertainment content that you guys who have been watching my videos throughout my channel would still find interesting. When can I get a BrawlDev plushie? Bro, I have to see what goes into the process of what is it? What is it? Manufacturing plushies, finding like what's like the best sweatshop in China to produce my plushie concept, and also set up a shop for it. I gotta have like a merch drop. I gotta tell everyone about it. Like I really, in all honesty, I really want my own BrawlDev plushie. I think that would be so dope. But that's only if you guys are willing to buy one. Yes, Newbert needs Papa BrawlDev with him during bedtime. Honestly, like that'd be so sick. I would want even for myself, I would want a BrawlDev plushie. On average, plushies go for about $25 to $30, I think. I would also have to think about overseas shipping as well, because I know a lot of you guys don't live in the US, so I would have to consider that as well. Okay, at least I know a few people in my chat would be willing to buy a plushie, so that's good to know. I would need mine hand delivered for sure, for sure. All right, we're about to reach the 2-hour mark, so I need mine handmade, bro. I cannot make a plushie handmade. That would be impossible. Okay, I need the the skills of the people who are working in the sweatshops to make them. I don't have those skills, only they do. Okay, they could probably make plushies better than me. But yeah, that's something for me to consider in the future. I will think about expanding. I will think about opening up my merch shop to have plushies, because I do think that would be a really cool thing to have. I need my plushie to magically come alive and teach me scripting. That'd be insane. That'd be worth way more than 25 or 30 bucks. That'd be crazy. Alright, but it's reached the 2-hour mark, so I think I'm gonna end the stream here. Thank you all for tuning into the stream. We learned a little bit about physics. I hope you did learn something valuable from the stream, but in the near future, probably within the next week or two, I'm gonna be getting this video out. I'm also gonna make a stream on my YouTube channel to kind of talk about, like, where have I been. It's been a couple months. I kind of disappeared without telling people. I'm gonna be updating everyone who's on my YouTube channel about that as well. And yeah, just create more amazing content for you guys to watch. I hope that we can get to 100,000 subscribers by the end of this summer. That's my goal. It's going to be a pretty ambitious goal, but I think we can reach it. It depends on how much effort I put out. And also with the amount of videos that I put out on my channel too, within that time frame. I will try and make that happen. It will happen. But yeah. Alright, that's where I'll end it here. I'm going to enjoy the rest of my Wednesday. I hope all of you guys enjoy the rest of your Wednesday too. And with that being said, this has been BrawlDev, as we've learned about a little bit of physics in this episode. And I will be signing out. Alright, take care everyone. Thank you all for tuning into the stream.